Using service mesh in multi-cluster Kubernetes environment for a disaster recovery use case. My name is Jun Wei, Senior Principal Architect from Equinix, presenting together with my colleague Mohsen Hoshman. In this talk, we look at challenging for distributed workload in hybrid and multi-cloud infrastructure. We choose service mesh to manage traffic for distributed workloads. We also look into the impact from the underlying infrastructure to workload deployment. We will present a demo with a cloud-based hybrid disaster recovery use case. In today's environment, with multiple cloud providers, enterprises may consider to distribute their workload across multiple providers. A simple scenario could be some workload deployed in one cloud provider for web-based services, while others in another cloud provider for analytics services, and the rest stay on-premise for data governance compliance purpose. To ensure the overall performance, enterprise will make sure to establish proper network connection between those distributed workloads. There are many use cases like this: global distributed application, cloud-based disaster recovery, cloud gaming, real-time edge analytics, etc. With the distributed workload in hybrid and multi-cloud environment, there comes the new challenges. For example, network latency in between workloads may impact overall performance. Being able to understand the workload behavior and being able to manage traffic among workloads become important in such environment. In this talk, we'll look into solutions to address those challenges. We choose service mesh to manage distributed workload in hybrid and multi-cloud environment. Specifically, we choose sidecar type of service mesh, Istio. There are two main features of Istio that are important for our purpose: traffic management and observability. In addition, we also look into network insight from underlying infrastructure that may connect workload together. As for service mesh deployment model, there are single cluster, single mesh, multi-cluster, single mesh, multi-cluster, multiple mesh. We choose single cluster, multi-cluster, single mesh. As mentioned earlier, now we look at how infrastructure may impact workload deployment. One example, if workload group A communicate frequently with workload group C, they should not be placed too far apart. If the latency in between these two work groups are too long, the overall application performance may deteriorate. Another example, if there are large amount of the data traffic in between work group A and C, the bandwidth and the capacity of the connection between the two needs to be large enough to handle the traffic back and forth. A third scenario is that when additional workload may be needed, either deployed in existing providers or into additional providers, the service mesh will expand accordingly. How to make a decision on which cloud provider to expand that workload? The visibility into the underlying network infrastructure would offer insight for such decision. In short, infrastructure insight can influence workload deployment strategy. Let's look at a specific use case example. This is a typical hybrid deployment case. Some of the workload is in a cloud, with the rest stay on-premise. Such workload deployment is managed by a single mesh with multiple clusters. When failure occurred to the workload on-premise, the workload can be failover to another cluster in another on-premise if that is available. If not, cloud failover could be a viable solution. When choosing cloud location for failover, it could be easier to locate a nearby region from the same cloud provider. In some cases, failover to another cloud provider could also be possible. In this case, the service mesh expands as the result of failover. The network metrics from underneath infrastructure could help Istio to make proper decisions on where the service mesh could expand to.
Now, let's look at a demo.
Thanks for joining. As Jun mentioned, we have a single mesh on top of multiple clusters. You can see one of them on cloud and another on-prem with 20 millisecond latency and with a curl time about 2 seconds. Now on-prem cluster goes down and service mesh automatically failover to disaster site in east region with about 60 millisecond latency. So we have front end on one regions and back end and another regions. You can see the RPS is 0 and this transition it takes time up to 2 minutes. Now the transition is done and front end is in west and back end in east, and you can see traffic is sending to another regions instead of the on-prem clusters, and this takes about 109 seconds, as you can see in the right side of the screen, and the curl time increased to about 6 seconds. We can see more details in Grafana dashboard regarding the success rate and the downtime. Now the orchestrator proposes a better location based on the different parameters such as cost and latency, and service mesh start doing workload orchestration to new regions. In this case, we switch workload from east to west, and now both backend and front end will be on the same regions. And you can see the curl time decreased to almost less than 400 millisecond, and you can see more details in, you can see that it's about 243 millisecond, and both of them in one side. Then the main side restore, and service mesh migrate the traffic to main side. And again, it takes time, and we can see again more details regarding the failover that we had. And after this transition time, the traffic is sending. You can see the traffic is sending to the on-prem side, and the curl time increased to 2 seconds in the right side of the screen. In this demo, we saw how easily we can leverage service mesh with orchestrator to migrate workload for different scenarios, and we showed the DR as a use case in a full automation way, and switching from one cluster to another cluster and from one region to another region. I appreciate your time. Thanks for attending.
In summary, hybrid and multi-cloud infrastructure enable distributed workloads. Service mesh can help to manage traffic for distributed workloads. Visibility in infrastructure help to ensure overall performance. We present a demo for a cloud-based disaster recovery use cases. That concludes our presentation. Thank you.